Hello, my Algebra 2 people. This is Mr. Hotard. Today we are continuing our education as concerns graphing polynomials. In our last lesson / last video, we were looking at how to graph polynomials when you had the unfactored and the factored form. This one is going to be looking, what if we just have one or the other? So what if I have the factors but I don't have the original problem, or what if I have the original problem but I don't have the factors? So we're going to do a few of these together. If you look at number one, this one's already factored for us. All right, so I can tell just looking at the problem, I can tell what the x-intercepts are going to be. I'm going to get x equals, if it factors into x minus 3, then the x-intercepts are going to be x equals positive 3 and x equals negative 5. So I know this graph's going to be touching the x-axis here at negative 5 and then here at positive 3. So I'm going to go ahead and put points right there. Now, how do we find the end behavior? If you think about what the original equation should have been, the original equation, let's see, we have x minus 3, have this 4 times. So that's like x minus 3, x minus 3, x minus 3, x minus 3, and then an x minus 5. How many total x's were in this problem? Give me a total of 5. We've got 4 of these and then 1 of these. So the original problem was like x to the 5th plus blah, 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 some other stuff I really don't care about. All right, so the original problem had 5 x's. All right, that is an odd or even degree. It is an odd degree and then a positive in the front. Now, how do you know it's going to be a positive? Because there's just a positive 1 in front of this problem. All right, positive in the front with an odd degree means the graph's going to be going down on the left, up on the right. All right, one other thing we need to pay attention to, how many times do we get these answers? We got x equals negative 5 just one time. So I know the graph's going to cross through there, but x equals 3, I'm getting that how many times? I'm getting that 4 times. That one has a multiplicity of 4. So it's not just going to pass through the 3, all right? If you get an even multiplicity, you might need to look back at your notes from last week, but even multiplicity means it's going to bounce off that point. So this graph's going to start at the bottom into the top. It's going to start down here. It's going to pass through the negative 5. It's going to turn back around, head toward the 3. But when I get to the 3, it's going to bounce off and come back up. Remember, even multiplicity means the graph bounces right there. If you're getting an answer just one time, it's going to cross through. Even number of times, it's going to bounce off. If you're getting it more than once but an odd number of times, it would flatten out and cross through. All right, so let's look at a couple others. If you look at, let's look at number 3. This one, are they giving us the original problem or the factors? They're giving us the original problem this time. All right, the original problem, I'm going to have to factor this in order to get the x-intercept. Now I can tell what the y-intercept is here. What's the y-intercept? It's negative 10. So I know it's the graph's going to touch the y-axis at negative 10. I'll go ahead and put a dot there. Now I need to factor this. GCF, what can I divide out of the whole thing? Well, I can divide by 2, but also there's a negative in front. Let's divide by negative 2. So negative 2, that's going to leave me with x squared plus 6x plus 5. And now factor what's left. What numbers multiply to give me 5, add to give me 6? That's 1 and 5. So negative 2, x plus 1, x plus 5. So I'm ready to get my solutions. Now, I don't get an answer from this GCF because there's no x in it, but I do get x equals negative 1, x equals negative 5. These are the places it touches the x-axis. So negative 1, and then out here at negative 5. These are my x-intercepts. Did I get any of those answers more than once? Nope. Each one got multiplicity of 1, which means the graph's just going to cross through at those points. So let's talk about end behavior now. If you go back to the original problem, degree, the biggest exponent was 2. Is that odd or even? That's even. Even exponent and a negative in the front, negative leading coefficient. What's that mean for the ends of the graph? It means both ends going down. So this graph going to start at the bottom. It's going to come up, pass through negative 5, turn around, pass through negative 1, keep going down, hit that y-axis at negative 10 and keep going down. All right, let's look at one more. I want to do number 7. Okay, this time, are they giving us the original problem, the unfactored form, or the factored form? This one, they're giving us the factors. They're giving us the parentheses. So our answers, we can get the answers, x equals what and x equals what? Positive 3 and negative 5. These are the x-intercepts. So let's put a dot here at negative 5 and a dot here at positive 3. These are the only places that graph's going to touch the x-axis. Now, how many times did I get that x equals 3? I got it 3 times. That's a multiplicity of 3. That's odd multiplicity. Remember, odd multiplicity means the graph's going to flatten right there. Now, how many times did I get negative 5? 2 times. That's a multiplicity of 2. That's even multiplicity. Odd multiplicity, it flattens out. What happens if it's even multiplicity? Even multiplicity, it's going to bounce. Now, what about our end behavior? All right, because they're giving us the factors, they didn't give us the original problem. So I had to figure out what the degree of the original problem would be. If there's 3 x's here, 2 x's here, that's a total of how many x's? 5 x's. The original problem was like x to the 5th plus blah, blah, blah. A bunch of stuff that I'm not really concerned about. All right, so that means it had an odd exponent, odd degree, with a positive in the front. What does that mean for the ends of the graph? It means it's going down on the left, up on the right. All right, so I know this graph, I'm going to start down here on the left, head up to the negative 5. Now at negative 5, I've got that 2 times. So what's going to happen at negative 5? It's going to bounce. So it's going to come up, hit the negative 5, bounce off, turn back around, dip down. All right, and it's going to come up, it's going to hit that 3. But what happens at the 3 since I'm getting it an odd number of times? It still crosses through, but it's going to flatten out. Going to flatten out, pass through the 3, curve back up, come back up. Okay, so now I want you to take a moment, just pause the video, go ahead and finish the rest of this handout. I'll be posting all the answers in Google Classroom so you can check to see if you got it right. All right, I hope you checked your answers. Now, second thing we're going to look at, some multiple choice questions. All right, we'll do a few of these together. Some of these are going to be just like the problems we did before. Like number 1, if I have 5x to the 3rd minus 6x, I want to find which graph matches. First of all, you can tell the y-intercept. What's the y-intercept got to be in this problem? It's 0 because there is no number without an x. All right, so graph has to touch the y-axis at 0, so it's definitely not D. Okay, now I could factor this. They both have a GCF, they both have an x. Let's see, that would leave me with 5x squared minus 6. All right, so I know I would have x equals 6, or rather x equals 0, and then whatever the answer is to that one. So let's see if there's an easier way to find this. If we look at the end behavior now, all right, end behavior, we've got an odd exponent, odd degree, positive in the front, which means this graph's going to go down on the left, up on the right. So it could not be A, it could not be B, it's got to be C. All right, now, how would you, if you needed to find these other x-intercepts, you could just set it equal to 0. You could add 6, divide by 5, take the square root. It's going to be a decimal number. And then it would give you numbers close to 1 and negative 1. Not exactly 1, but close to it. That's why these other x-intercepts are really close to 1 and negative 1. Okay, I want to look at a couple more. If you look at number 3, it says y equals a, x plus 1, x minus 2, x minus 2. Where a is greater than 0. We don't know what a is, but we know it's greater than 0. Does that mean positive or negative? It means it's positive. It's starting with a positive number. Now, how many x's are in this problem? There's 3 of them. They're giving us the factored form. So the original problem would be like positive x to the 3rd plus blah, blah, blah. Some other stuff. Odd degree, positive in the front. What's that mean for the ends of my graph? Down, then up. All right, has to be going down on the left, up on the right, so definitely not graph D. And then we can tell what the x-intercepts are. I'm going to get x equal negative 1, and then I'm going to get x equals positive 2 how many times? Twice. Multiplicity of 2. So what happens if you get a multiplicity of 2, or any even multiplicity? It's got to bounce. So which of these graphs bounces off of positive 2? It's graph A. All right. This graph starts at the bottom, ends at the top. It passes through negative 1. It bounces off of 2. That's graph A. All right, I want to look at one other problem. Now, a lot of these problems don't give you any numbers at all. Like, for example, number 5. Right, which of the following graphs best illustrates this? If we have y equals a, then x minus b squared, and x minus c. It tells us A is less than 0. Does that mean it's positive or negative? It means it's negative. I've got a negative in the front. And then B is not equal to C. That just means these are two different numbers. All right, so first of all, let's look at what the original problem would be. These are the factors. So I've got a negative in the front. All right, and then I have, let's see, this is squared, so that's going to be 2 x's, and then another x. This is total how many x's? 3. So my original problem would be like negative something x to the third plus blah, 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 blah. So now, odd degree, negative leading coefficient. What is that telling me about the ends of my graph? Going up on the left, down on the right. So definitely not graph C, definitely not graph B. It's either A or D. Okay, now, whatever the answers are, I don't know what B, C are. I don't know what these numbers are. But I know I'm getting some answer, whatever B is, x equals B. I'm getting that answer how many times? Twice, with a multiplicity of 2. So it's going to bounce at that point. And I'm also getting a different answer, x equals C, where it has to cross through. So I need a graph that crosses through one point and bounces off another point. That's graph A. All right, so I want you to try to figure these out. I'll be posting the answer key to all of these online. Good luck. This is Mr. Hotard signing off.